Everybody does their little beginning of the year video showing what they want to accomplish and what they're doing and what's going on and what's happened. And I guess this is kind of my little video, although it's getting a little bit later in the year for that. The area you're in here is an area that I've used for several years for storage, and it's getting repurposed. So I talked earlier about a shop remodel, and we're working on that slowly as it progresses, and this is part of the area that's going to be redone. The reason I'm back here working on it today is several reasons, and I'll talk about all three of them. One of them is a little Logan turret lathe that I've got that I'll show you that's been hidden away here in the archives for several years. Another one is phase converters, and the main reason that I started in here today is I said previously that I bought a little speedy melt furnace several years ago. That little speedy melt furnace is what I wanted out because I'm working on foundry stuff quite a bit. I've got quite a few casting things going on. You've seen my little Atlas index centers. I'll put a link to those up above. But as I progress with those, I'm trying to get the foundry a little more efficient because I'm going to shift part of my endeavors over towards that foundry work. I've got quite a call for some of the castings that I do, some of the guards for on the shapers and that type of thing. So we're gearing up for that. The weather's getting a little bit nicer, so that's the main reason I started in today, kind of reorganizing and cleaning this, is I wanted to get that furnace out and start looking at it and see what's going to be involved with getting it up and running, because I bought it several years ago and played with it a little bit, cleaned it up, but never really had it running. So it's time to get that going. We'll get to that here in a few minutes. I've got it pulled outside already. The first thing is my little Logan turret lathe, and let me switch the camera around and I'll show you what's going on with it. So this is a Logan turret lathe that I bought several years ago. It's a model 830. It's actually the first turret lathe that I had any experience with, and I knew nothing about it, and I bought it for a pretty fair price, and it basically paid for itself on the first job it did. And what it ran at that time were these little parts right here, which are contender hammer extensions. These are early model steel ones that I produced, and these have not been blued. I still got a tray of these that could be polished up and thrown in the bluing tanks, and they'd be a good saleable product. But the first operation was done on this little lathe, and it started off with square stock. We went ahead, turned them down, drilled them, threaded them, knurled them, and then back beveled them and parted them off. So that was what was involved with those. Like I say, I still got quite a few of these kicking around. I probably got a couple hundred of these, but the time when they were popular is pretty much gone now. Everybody's either got them or producing different ones on the Encores. You can't use a steel one, you want to use an aluminum one. Anyway, neither here nor there. So this is a little 830 lathe, and I do want a little information about this if anybody's got it. But when you compare these to the Atlas turret lathes, like the Atlas that I built, there again, put a link up here if you haven't seen those videos, this is a better turret lathe for the most part than the Atlas is. It's quite a bit stouter. It is more rigid. I won't say it transfers more power, but it can transfer more power efficiently. One of the downsides to this is the flat belt system. And the flat belt system works fine, other than if you don't have, with their particular system, if you don't have it set up on a solid floor, everything level, and perfect alignment with the support leg on the back of the counter shaft assembly, why it tends to want to walk this belt off when you put load on it. So you have to fiddle with it a little bit. And at some point, I may convert this over to a serpentine belt. I haven't decided for sure yet, but if I get that far and do something, it's a pretty good design. Once you've got your belts on, you put them on whatever you want. When you drop the cover, why that actually tensions your belt. When you lift it up, it locks there automatically. When I actually got this and started using it, I knew virtually nothing, even less than I know now. So I'm going to work with this little lathe. We'll clean it up. It's sat out here. Got a little bit of water laying in the pan and everything. It's just dirty and gunky. It'll clean up nice. I've got a little surface rust on some of these pulleys, but it's all just surface stuff. So it won't be too long. This will be moved out into the other part of the shop, and we'll start doing a little bit of work to it. So I'm kind of anxious. I like these little turret lathes, so it'll be fun to get up in production. Now, what I would like information on, if anybody's got it, is I would like anything I can find about the bar feed assemblies for this. I've got the patent drawings for it, and at some point in time, no matter what, I will reproduce a bar feed for it, because it's a neat little setup. Now, one of the advantages to this with the collet closer on it is it doesn't draw your material back in. It's the style collets are on it is when you lock it in place, which is that position right there, why it closes down on the collet, but it doesn't draw your material back in like the 3C collets and that type of thing, 5Cs and all of those. So it's got a little bit better collet assembly. This also takes 3/4 inch tooling, just like the Atlas stuff. So everything that I've added onto the Atlas will fit on here, or all the tooling that I had here, a lot of that I'm already using on the Atlas. So, but the bar feet assembly, it's kind of a unique setup. I think it's a cool setup, and like I say, I would like to have a bar feet assembly on this. We're in the locked position here. When you come to that position, it unlocks it. From there, there's an assembly that goes on here that actually pulls your bar on in. And this has got stanchions on it, and it's got a support bar that comes out here with a gear tooth, or a ratchet style tooth on, series of teeth. And when you advance it forward, why, there's a dog on it's hooked to the bar itself, and it moves forward, drops into the next ratchet position. So then once it's advanced at the proper amount, you go back to that position, and it's still held in place because your ratchets held your bar in position. It goes to advances back to the next pickup point, and there's where it locks back into position. So neat little setup, but I don't have any of the parts from here on back. They're relatively rare from what I've seen. I've only seen 3 or 4 sets over the years, and they were all on lathes, and nobody was interested in parting with them. And I have seen a couple of those that they wanted a substantial amount of money for, and it's in reality another one of those that's probably not worth spending a whole awful lot of money on a bar feet assembly for them, but I would like to have it. So we'll do some castings and some pattern making at some point in time and do that. So anyway, there's one of my little toys out here that will be an interesting project later on. The next thing is phase converters. And actually this Logan is run off of a 3-phase. When I originally got it, it had a single phase 110 motor on it, and it was a reversible motor as long as you just wanted to go forward. There was no reverse on it. So I ended up and changed out the motor. I put a 3-phase motor on it. And this is one of those examples where a rotary phase converter is just as good, if not better, than a VFD on one of the lathes. Now, I run both VFDs and rotary phase converters. My smaller rotary phase converter is this one down here. It's actually underneath the lathe. And this is one that I built, and we've got our start and stop buttons, run button, and there's our little motor, that 3-phase motor that we start, and it powers the 3-phase motor on the lathe itself. But this is one that I actually robbed parts off of to get it running, because I wasn't running my bigger phase converter, and that's the one that's more of interest than this. Another of my projects is this phase converter over here. This is the phase converter that I'm going to put back together and get running, and I'll show you inside the electronics box what's left of it. Like I say, we've robbed parts out of it. But there's a couple reasons for getting this one going. One of them is for a sand molar. So I'm going to build a new sand molar based after Steve Chastain's design of a sand molar. Previously I built a sand molar. I'm going to use that shell and part of the components on it, but the drive system I was not real happy with. So just as another one of those projects, I'm going to do another sand molar. There again, that goes with the casting part of it. I want to be able to process my sand a lot more efficiently than what I'm doing now. We'll have a big enough motor that we're going to need a little more phase converter than what I've got on this little phase converter. I'm going to put a 3-phase motor on it. You know, they run a little bit smoother power, a little better transition, so that's what will happen. 3-phase motors are, if you can find them used, are relatively inexpensive. They're, you know, they're pretty much bulletproof. The only thing that will really go wrong with a 3-phase motor to speak of is the bearings that go out of them. And it's just from being run for years and years if you've got an older one. That's one of the things that's going to happen on this phase converter. Bearings were loud in it. It ran fine when we had it going, but the bearings needed to be replaced in it. So when I pull it down and start reworking it again, we'll put new bearings in it and take care of that. There's also going to be quite a few changes to this, of course, but the other reason is, and the reason that we built this phase converter to start with, is I have a fairly substantial piece of equipment I don't have it down here yet. I bought it years and years ago. It's been stored undercover, and I haven't really had good access to it. So I'm hoping it's in salvageable condition that I can get it down here this year, and it runs off of a 10 horsepower 3-phase motor. So that was the original reason for building this phase converter. I'll hopefully be able to share that project with you. I'm afraid it's going to be in fairly rough shape, but I'm kind of ashamed of that. But we'll see if we can't get it down here. That's a restoration project that I'm really excited about if I can make that happen. So we'll see what happens. So anyway, that's part of the reason for getting this phase converter going. Now, when we originally built this, why we wrapped a rope around the motor shaft and gave it a pull and got it started, and then it worked fine. We'll change that all around and put start capacitors on it and bring it back to the way it needs to be. And I'm probably just going to actually chop the shafts off, because it's never going to be run again in my lifetime as 3-phase motors. And what we've got is two 7.5 horsepower motors there hooked together, designed to where we could run one, or if we only needed one, or then we could switch it over and run both of them. Produces power just fine, does what it's supposed to do. We had a main disconnect switch on it that we started, had a start, run it on 7.5 or 15 horse, and then a stop button on it. Run capacitors are in this box, and there again, we'll change all of this design. We'll leave the main stack, there's no reason to change that, but the control box and everything will probably rework. We've got our two big starters in there, and we had another, at least one more start in there. I don't remember, or run relay in there. Like I say, we've robbed wiring and parts out of this to get other projects going. So this is a project we can look forward to seeing happen. So, you know, another one of those. Now, let's go out and look at the main reason for me taping any of this is this little speedy melt furnace. Well, this is my little speedy melt furnace, and it is made by, or was made by, McEngleton Heat Treat Manufacturing Company and Manufacturing Company. These are popular little furnaces, you know, when you can find them. A lot of these were in a school, or were in the school shops, which is where this one probably started out life as, I'm assuming. This is a C10. Normally what you're seeing is the B16s and that type of thing. The C10s apparently doesn't have quite the heating capacity. It won't do cast iron, which is fine with me. It will do everything I want for a small aluminum furnace. So I think I'm excited to have it. I managed to get the blower mower running on it and a few things like that, but I never had it running after that. Got sidetracked on other stuff. So it's got what they call a drag and eye safety system on it and all that. So I don't understand everything about the safety systems there is. I've got documentation on it, and I just downloaded the manual for it. So we'll get around and start going through it and seeing if we can start testing things and make sure it's going to run. I've got the fan running, although I don't know, you know, if it's running to the speed that it needs to be doing to provide enough air. You can apparently run these off of either natural gas or propane. I would imagine it was set up for natural gas. Most of these were in a school setting. But we're going to run it off of propane, and when I got it originally, there was a whole lot of little mud dauber nests in it and that type of thing. So I don't know if internally we've got plugged lines and that type of thing. This may be one where we're taking everything apart and going through to try and get it running again. Anyway, we'll see what we're going to think it takes to. Anyway, we'll see what it's going to take to get it running again, and hopefully we'll get it going before too long. It's in relatively good shape. We got quite a bit of corrosion on the outside and everything. We may try and clean that up just because we can before we actually put it into service. Internally, it's the lining and it's good. Let me move you over so we can see inside it. So we've got everything to go on here with it. Like I say, internally the lining looks pretty good. I don't see a real problem with it. It looks like it may have the plinth looks like it's kind of glazed into place, and I'm not sure we've got drain. Maybe there's drain holes underneath it, if they're clear or if they've been glazed too. So we'll have to look at that. But the lining's in pretty good shape. You know, I don't see any major spalling or cracking on it. We've got a little bit here in the exhaust port, but and just in the tray on the exhaust port here. Everything inside looks good. So I think it's a good solid little furnace. I think hopefully with just a little cleaning up and a little work, we'll have a good working furnace. A lot of what I've got planned for casting this year is going to hopefully be in cast iron. So we're not going to worry about this furnace for that. I'm fine with this one being an aluminum only furnace. And the C10 apparently didn't heat quite as fast as the B16s and that series of furnaces. There again, probably for a school setting. It has, I think it probably could be set for a dip out pot, is the way part of the time they intended these to be, with this portion of it. So we may look at that, because I'd be perfectly happy with a lot of the things that I do in aluminum with a dip out pot, if I can get the capacity to do it. So we'll just see how it develops and what happens with it. But anyway, that's kind of my plan for the year. We'll continue with projects and see how far we can go. So anyway, hopefully this is a little interesting to you. And any comments or suggestions, leave them in the comment section for me below. And as always, thanks for taking the time to watch.